a ball is attached of mass m is attached to the lower end of a string which is held vertical with a spring constant k. The upper end of the spring is fixed. The ball is released from rest with the spring in its normal position. It comes to rest again after descending through a distance x. So we have to calculate the various values over here. If I consider a spring over here and there is a ball of mass m attached at this point, and the spring in this case is unstretched. Now when I release the ball, the spring will extend and will come to this point, okay, and will come to this point where the ball again comes to rest. It means that if the ball comes to rest and this distance is given as x, okay. Now in this case, first of all let us see the first value, okay. By law of conservation of energy, whatever is the potential energy held by the mass at this height, that is, if I take this as a ground, so whatever is the potential energy of the ball, that is equal to mgx, will be equal to the energy stored by the spring in this case. So the energy stored by the spring will be equal to, the potential energy stored by the spring will be equal to half kx square, okay. By law of conservation of energy, half kx square should be equal to mgx. So over here we have to calculate the value of x, so 1x and 1x will get cancelled out. X will be equal to 2mg divided by k, okay, which is option number B, okay, which is option number B. The second thing they have given is the ball will have no acceleration at the position where it has descended through a distance x, okay. Now what happens over here? What happens whenever a spring is stretched, okay? I will solve the part B over here. Let us say it is stretched by certain amount. Let us say it is stretched by a certain amount. Let us say x1, okay. Whenever it is stretched by x1, there are two forces acting on the ball, okay. The first force will be in the downward direction, which is equal to mg. The second force will be in the upward direction, or over here I will mark the upwards force as k into x, which varies as per the x1, okay, or I can say k into x1 in the upward direction. And let us say that the total acceleration in this case is in the downward direction, which is equal to ma. So the net force acting on the ball will be equal to mg in the downward direction minus the spring force in the upward direction will be equal to ma, okay, will be equal to ma. So now over here it is given that the body does not have any acceleration. It means that the acceleration of the body is equal to 0. So kx1 will be equal to mg. If I substitute a as 0, if I substitute this value as 0, then mg will be equal to kx1, or kx1 will be equal to mg. Now mg can be written as kx, over here I will write this as mg can be written as kx divided by 2, okay. So I will write this as kx divided by 2 is equal to kx1, which implies over here x1 will be equal to x by 2. So our option number C is also correct, okay. Now the third option over here, the ball will have an upward acceleration equal to g at the lowermost position. When the ball reaches the lowermost position, over here, now let us see the forces acting on the ball, okay. There will be spring force which acts in the upward direction, which is equal to kx. There is mg which acts in the downward direction, which is this part. Let us see the x over here. The x over here is given as x we have already found out. X over here we have already found out, which is equal to 2mg by k, okay. X will be equal to 2mg by k. So over here the total spring force will be equal to 2mg by k. So when I substitute the value over here, the spring force is equal to 2mg, which acts in the upward direction. So obviously this force is greater than the mg. So the net force will be equal to the spring force, which is equal to kx, minus the mg, which is equal to 2mg minus mg, which is equal to the net force is equal to mass into acceleration. So acceleration will come out to be g, okay. 2mg minus g will come out to be g. So acceleration in this case at the lowermost position is equal to g, okay. That is the option number D is also correct, okay. So the correct options are B, C and D.